This lesson will cover solving quadratic equations. The learning goal is to solve quadratic equations using different methods to learn how to simplify radicals. Your success criteria is you can identify when you need to solve a quadratic equation and when to solve it, and you can simplify radicals and express solutions in simplified radical form. So many quadratic equations will not cleanly factor. You can still solve them though using the quadratic formula. Now given the equation in standard form, ax squared plus bx plus c, the quadratic form is x equals negative b minus the square root of b squared minus 4ac all over 2a. So quadratic formula will always work, always give you the roots if they do exist. It's a very, very handy formula to have on hand. Now, when solving equations using quadratic formula, often, and very, very often, the answers will be irrational. It won't be a nice clean decimal or whole number. So common practice in mathematics is leaving an answer in exact form using radicals. So what is a radical? Well, a radical is a square root. So the root of, let's say, 2 is a radical. The root of 36 is also a radical. But root of 36, that's still 6. We can simplify that. Root 2, we can't. So that's why we keep it in this particular form. If we were to put it in a calculator, you would get an irrational decimal. We'll get that in just a minute. A radicand is what's inside your radical. It's what's inside the root. Sometimes you might hear me refer to it as like the innards of the root, but it is in fact called the radicand. What is a mixed radical? A mixed radical is when you have a radical that you can't simplify, so for instance root 2, and it has a coefficient. So 5 root 2 is a mixed radical. It's 5 times root 2. Why keep answers in radical form? It all comes down to accuracy. Root 2 itself is a irrational decimal. It has no end. If you were to, in real world applications, if you rounded the root 2 and you were doing some very, very fine-tuned mathematical calculations, like in anything like in medical science or architecture, you will have then error. So to prevent that, we keep our values in exact form, so we know, this was the root of 2. It wasn't this kind of rounded decimal. So it's all about accuracy of the mathematics. I don't think I spelled that correct. It's all about keeping accuracy. So, simplifying radicals. We want to keep radicals as much as possible in their lowest form. But what happens if a radical appears in the denominator? So having an irrational denominator is similar to a kind of a grammar error in English. To be in the simplest form, a fraction should have a rational denominator. So for example, if I have 1 over root 2, I don't want that. I don't want that root 2 down there. So instead, if you ever encounter a radical in the denominator, you're going to multiply your denominator and numerator by that radical. So that would give us 1 times root 2 would be root 2 on the numerator. And here, root 2 times root 2, remember that a root times itself is going to cancel the root, so that must be 2. So root 2 over 2 is the same as 1 over root 2. We just prefer to have rational denominators. Now, like fractions, we want to easily read and use a radical at all times. A radical answer must be in lowest simplified terms, and this takes the form, most often, of a mixed radical. So we're going to express the root of 250 and 4 root 75 in lowest terms. Now, the way we go about this is with radicals. For instance, let's do root 10 very quickly. Root 10 can be split up into root 2 times root 5. You can actually break up the radicand into its factors. So root 10 is root 2 times root 5. Now, we wouldn't do this because root 2 and root 5 themselves are, we can't square root them. They're not perfect squares. So we'd actually keep this as root 10. It's its lowest form, its lowest term. Root 250, we can do something with this. We can express root 250 as the square root of 25 times the root of 10. Why square root of 25? Because 25 is a perfect square. That's 5. So that's 5 root 10. That is our fully simplified form for root 250. For root 75 is a mixed radical, and we can actually still simplify it. So for root 75, we want to think of numbers that factors of 75. 25 is one of them. So we'll have 4 times root of 25 times the root of 3, because 3 times 25 is 75. And that gives us 4 times 5 times root of 3. And 4 times 5 is that's 20. And then root of 3. So it's all about simplifying the coefficients of the radical with any numbers you're able to kind of break apart or take out of the radical itself. So this comes in handy when we're solving quadratic equations, because the quadratic formula has a root sign. We're going to get radicals in this. Okay, let's go ahead and solve. So we're going to use quadratic formula here. So we have A as 1, B as 8, and C as 2. So we have x equals negative b minus the square root of b squared minus 4ac all over 2a. Remember, it's plus and minus after the negative b, because when you square root something, it's going to be a positive and a negative version of whatever it is. For instance, if I do root 4, that's equal to 2 and negative 2, because 2 squared is 4 and negative 2 squared is also 4. So just keep that in mind, that you always have two versions or two values when you square root. So that gives us negative b, so that's negative 8 plus or minus 8 squared minus 4 times 1 times 2 all over 2 times 1. That gives us negative 8 plus or minus the square root of 64 minus 8 all over 2. That's going to give us negative 8 plus or minus the root of 56. And that's where the radicals come into play. We cannot square root 56 because it's not a perfect square. However, we can get two values out of this. Now, we can simplify the roots of 56. So off to the side, or we can just continue on in the same lines. Negative 8 plus or minus, so root of 56, we have to think of two factors of 56, one of which is a perfect square. You can do root 4 times root 14. If you have trouble finding the factors, just make a factor tree, or just write the factor pairs out. It's a little bit of work, but it gets you there. That's 1 over 2. It's negative 8 plus or minus 2, because root 4 is 2, root 14, all over 2. In this case, we have negative 8 plus or minus 2. 8 and 2 can both be divided by this 2, so we can actually simplify here. It gives us 4, negative 4. So now we have our x value equal to negative 4 plus or minus the root of 14. So you can either do this as plus or minus, or you can do negative 4 plus root 14, or negative 4 minus root 14. Those are our solutions to this particular equation in fully simplified form. Now, radicals are often used in operations, and as such can be added, subtracted, multiplied, and divided. Basically, any operation can act on them, but the base operations are there. So let's actually go ahead and simplify what some of these equations might look like. So when you encounter these, you do need to work with it with the idea that different radicals they're different. And that's where our algebraic skills come to play here. For instance, let's do root of 2 plus root 3. This is the same, or think of it as kind of x plus y. I can't add these. It's the same as think of it as like x plus x squared. I can't add these. These are not the same variables. So radicals work in the exact same way. They need like terms. As long as two radicals are exactly the same lowest term, you can then add and subtract them. Multiplication and division is a different story. We'll get that in a minute. So when we have these kinds of questions, or when we're working with these kinds of radicals, we need to get them in the fully simplified form first. So we have 2. We have root 12. That's going to be a root 4. No, let me do 3 first. 4. 3. Plus root 8. Root 8 is, we'll do root 4, 2. Minus 3. Root 18 can be root 2, root 9. And then 48. 48 would be, we can have 412, so root 4, root 12. Or we can do root 3 and root 16, I believe. Yeah. So 2 and then root 3. Root 16. So we can go through then. That gives us 2 times root 3. Let's actually simplify this. So 2 times root 2, or 2 times 2 is 4, so that's 4 root 3 plus 2 root 2 minus, that's 9, root 9 is 3, so minus 9, here's 3 times 3 is 9. Root 2, and then plus root 16 is 4. 4 times 2 is 8, so that's 8 times root 3. And now we have in fully simplified forms, and we can now start adding and subtracting. So here we have root 3 and root 3. So 4 plus 8, that's 12 root 3. And then we have 2 root 2 minus 9 root 2. These are like terms, so both have root 2. So 2 minus 9 is minus 7 root 2. And we can't simplify further because the root 3 and root 2 are different. They are not like terms. So our fully simplified form of this expression is 12 root 3 minus 7 root 2. When you multiply and divide, though, things are different. Just like with variables, for instance, I cannot do x plus x squared. Can do x times x squared. This we use exponent laws. In radicals, it's a little bit different. If I have root of 3 times root of 2, that's the root of 6. If I have then root 10 divided by root 5, that's going to give us root 2. So you're able to divide and multiply the radicands, the insides, but you can't add and subtract them. So simplifying this, works in the same way as variables. So we have 2 times 4, that's 8. And then root 5 times root 3, that's root 15. And then here, I wouldn't simplify this further because I know that I got 15 from root 5 and root 3. Both of those are not perfect squares. So root 15 is technically its lowest simplified form.